That should pay for my college.
Utilities, you know.
Okay,
The paper cups.
so today we're going to take a look at the shortcuts that I was telling you about before. So once you know the shortcuts, unless I tell you that you have to use the limit definition, you can just go right to this, okay? So the first one is derivative of a constant function. And yes, there's a C. C stands for? So it's right here. The derivative of a constant is 0. Why would that be? Okay, so we'll think about what's a constant function. What does that mean? You know what that means? It's like y equals 3. What does y equals 3 look like? It's a straight line, but what direction? So an example, in fact I have it written here, like if we had y equals 3, so picture here's 1, 2, 3. Remember, derivatives are slopes. So if you think about the slope of a constant function, a horizontal line, the slope is always going to be 0. So m is 0 here. That means the derivative of 3 is just 0. Okay?
Whereas it doesn't give like an equation or is this?
So it's kind of like this. If I said y equals square root of 5. Square root of 5 is a constant. So if I said, well, what's y prime, or the derivative of square root of 5? That's 0. Sometimes I'll give you like a y equals or an f of x equals, and then I'll say find y prime or find f prime. And if you see d dx, that just means take the derivative of 3. So the derivative of 3. Again, whatever's inside, this is like saying, what's the derivative of y equals 3? So derivative of 1,000 is 0. Derivative of negative 17 is 0. Anytime it's a real number, it's 0. Okay? Power rule. This is a big one. This is the most probably commonly used one. And this says if we have x to a power, we're going to move the power to the front, so n goes to the front, and then we take one away from the power. So here's our example. We take derivative of x to the 5th. So that becomes 5x to the 4th. Now remember, when we did this before, this would have been a nightmare to try to find the derivative of with the limit. Okay?
Oh, yeah.
You would have had to have written out x plus h to the 5th power. And then you'd have to use either like binomial theorem or Pascal's triangle to multiply it all out. It would have taken forever. Now, much easier. So for example, if we had x squared, so every time we've seen an x squared, we'd have to do the FOIL. But now I'm telling you, what's the derivative of y equals x squared? 2x to the first, so just 2x. So much easier.
What if it's like a polynomial?
So why do you tell us after we already
You know why. Okay, next one. So if we have a constant inside, or not inside, but constant times some function, this is where we'll actually apply it to polynomials. So if there's a constant, we could just move it to the front. So it's as if we were to do, okay? So if I move the 4 to the front, I could do the derivative of x squared, which we just said, what's the derivative of x squared? 2x. Now, I will tell you, I never write it out like this.
Did you just do another formula inside of another formula?
Wow.
So,
What's the derivative?
okay, whenever you have a constant, the constant can go out in front. And then we could just do the derivative of x squared. Now, as I just said, I never write it out all these steps.
Oh.
I just look at the 4, the constant just gets multiplied by whatever the derivative of x squared is. So just imagine, you could just move the 2 to the front still. 2 times 4 is 8. Take one away. We get x to the first.
So you just took the thing from above.
Exactly. So let's say I gave you 6x to the 8th. So what would y prime be? 6 times 8, so that'll be 48 x to the 7th. Okay? So now we can deal with these really large exponents in a much easier way. Like I said.
I was thinking about ACT and there's a Pascal's triangle on the poster.
Did it help you at all? Nice.
But I was thinking if you guys already know this, you know the poster. You should make one. That's your final.
Not so much. Okay.
I don't have, like, you can spell.
It has nothing to do with, well, it has little to do with calculus. Okay, next one. If I have, okay, so now we're leading up to polynomial. So if I have 4 plus 5x to the 3rd, I can take the derivative of each part. So it's kind of like distributing the derivative part. So take the derivative. What's the derivative of 4? It's 0. And what's the derivative of 5x to the 3rd? 15x squared. So I just get 15x squared. Again, I'm showing you how to write it all out, but I'm not going to expect that you write it. From now on, we'll just say, oh, what's the derivative of 4? It's a constant, so that's 0. And then we do plus, and then we do the derivative of that part. Okay, good so far? All right, so take a look. So we are going to use all of those ideas kind of wrapped up into a polynomial here. This is a 4th degree polynomial. So what should we do? We're going to do y prime, or dy dx. It's the same thing. Remember, it's just notation. 12 x to the 3rd minus 18 2x over 2. So that just becomes x.
It's 1x over 2. Is it the same thing? No.
So this is really like a minus 1/3 x. It would be x to the 0, or minus 1/3. And then what happens to the 10? Goes to 0. Just remember, anything that just has a degree of 1. So if I have a 1/3 x or a 2x, remember, think y equals mx plus b.
What do you do with the fractions? How do you do the fractions?
So the 2, like this part, it would become 2x over 2.
So you don't touch the bottom part.
Right, the bottom part stays.
Wait, can you do it more?
It's obvious.
No. You mean take another derivative?
Yeah.
Okay. So what we'll also learn is 2nd and 3rd derivatives. We only find dy dx. I'll show you some notation. There is a 2nd derivative. And we actually, one of the nice things about, well, you might not think it's so nice, but actually applies to some of the stuff that you've been doing in physics. And so when you take the first derivative of a position function, you get velocity. And then the 2nd derivative is acceleration. And then there's even a 3rd derivative. It's the first derivative of position is velocity. The 2nd derivative of velocity, or 2nd derivative of position, is acceleration.
Yeah, because that's over s squared.
It's over the change.
Yeah.
Okay, but no, if they just tell us to do dy dx, we stop after one time.
But technically you could do it.
Not if the directions are to find dy dx. If it said find you put a y2 over dx2, that means the 2nd derivative. Anybody want to try b? You want to come up, or you want to just tell me? Okay.
0
Minus
6x plus. So it's
you can write it out.
x
4
to the- can I just say this?
4x to the 3rd over
8
plus.
actually,
Yeah, we'll do it in the next step.
Plus,
Just
No, just 7.
Just 7, because it would become x to the 0, which just goes away. Anytime it's x to the first power, we just take the coefficient.
Just 1.
Okay, so now we get negative 6x to the 5th, and yeah, just reduce that, so that'll be 1/2 x to the 3rd, or you can write it as x to the 3rd over 2 plus 7. Questions? See how nice the shortcut is?
It's going to get complicated.
It does. It does get complicated, yeah.
It's not.
It has to.
That's the goal of fun. Make everything complicated.
No. Well, we just made things easier.
To simplify.
All right, simplify.
and then make more.
All right. Let's horizontal tangent. So we did this before. When we have a horizontal line, what kind of slope do we want? And if I want a slope of 0, what is the slope? It's also the derivative. So we want to make the derivative y prime equal to 0. Do I have anybody that would? No? Everybody's, I should just do it.
Well, I mean, I can like.
Did you do the first part?
Yeah. You find the derivative, and then you just
Yeah.
set it equal to 0.
Yeah.
4x
So
to the
first,
third
so it's going to be 4x to the 3rd.
minus 4x plus 0, which is
Right. Are we okay with that part?
Yeah.
All right, so I want to set this equal to 0. So how do I solve that? Factor out 4x, good. And I get
4x equals 0 and x squared equals plus or minus 1.
good. So you can either just keep factoring, or you could just set them equal to 0. Either way, you're going to get the same answer. So at x equals 0, -1, and +1. So at x equals 0, -1, and +1, we have horizontal tangents. Now, what are the actual tangents? How do we find?
Oh, like this.
How do we find the actual lines? What would we do? Any ideas?
Oh, you just use the slope and then.
Well, the slope is what?
0, 1, 0.
We have this equation, which it's an x to the 4th. It kind of looks like this. Just kind of looks like a W. So
You find the converse.
so where are the horizontal tangents? They're here. What are the actual tangents? We can, if we plug these back in, that will give us the equation for the tangent lines. So if I plug in 0, what do I get?
0.
So at x equals 0, we get y equals 2. That's one of them. Let's do at x equals, actually it doesn't matter, plus and minus 1 is going to give us the same answer because this is to the 4th and this is squared. So what happens when we plug in 1? We get 1 minus 2 plus 2, so it's 1. Okay. Good, questions? What's wrong? No. I don't see any.
So why do you have the y equals 1?
Just- You can get, yeah.
How come y?
Oh, when you plug it in. Plug in 1. So like y equals 1 to the 4th minus 2 times 1 squared plus 2.
But why is there next to
So
Because the horizontal tangent is the y.
the actual tangent line is the y equals.
What the tangent? Tangent line?
Yes. Horizontal tangent.
No, the name of the page goes pretty good.
I think my eye is people can call
His first name is Rufus, so that's probably all.
I was hoping for Jack Jr. I told him every day. When he was about 15, you didn't know Jack Jr.
His first name is Jack.
Okay, so can you see this graph? This is the actual graph. And do you see there's 3 places where there's a horizontal tangent? So at 0, can you see it's right here at y equals 2? And then here at -1 and +1, we have, notice these end up giving you the same tangent line. Do you see how that? Okay.
Wait, so
Yes.
this is like a good way to check. You should
Yes.
Do it like this.
You can definitely check these on your calculators.
If it's a calculator.
Yes, if it's a calculator, okay part. Okay, now we get to the more, that was kind of the easy stuff. Now we have the product rule. Okay, so derivatives, it's not like we could just take the derivative of this times the derivative of the second part, okay? It just doesn't work that way, okay? Now, you could FOIL this, but I want to show you the product rule because there will be occasions where you can't multiply. Like we're going to learn all the sine, cosine, tangent ones. So this is what we do. We take, let's say you have some function u times some function v. So you kind of separate it into 2 parts. So you're going to keep the first part the same times the derivative of the second part. And then you're going to take the second one times the derivative of the first. Now, because of commutative property, you can switch things around. Here's a different notation with prime. So it's uv prime plus vu prime. Okay, so the first thing I would do when you're first learning this is just kind of figure out what are you going to make u, what are you going to make v. So I will make 2x plus 1 is u, and 3x minus 5 is v. And then over on the side, just figure out what is u prime, and what's v prime. Okay, so what's the derivative for u? Just 2. Remember, look at these. This is the equation of a line, y equals 2x plus 1. So another way to think of it is what's the slope of that?
Also, you could do it like we just
You could.
did, right?
Yeah.
Like x goes away.
Yes, so you could do it the way that I just taught you, but you can also remember back to anytime you have the equation of a line, it's just going to be 2. Or it's just going to be whatever n is.
Yeah, I did that on the practice quiz. There was one point, like, there was a piecewise function.
Yes.
I just wrote m is equal to 3. Just
Right,
yes.
that's fine if it's y equals mx plus b.
Yeah. Okay, cool.
What's v?
I was really confused.
No, that's fine. What's v prime on the?
3.
That's 3. Okay, so we're going to use this. Let's use this formula. So it's u, so 2x plus 1 times, which is 3, plus v times 2. So we get 6x plus 3 plus 6x minus 10 to give us. All right.
Made it seem like that was way worse.
Oh,
So it's not that it gets. The product rule was the easier of the 2. The quotient rule is a bit more complicated. Yes, no? Oh, yeah, sure. So I have a little rhyme that may or may not help you. You could also memorize the formula. So in Chapter 3, whatever helps you to memorize. There's a lot of memorization in Chapter 3. I know flashcards seems kind of elementary school, but it might help to even make like all the formulas or to just make a sheet and write them all down. Whatever helps you to remember. I think flashcards are actually really great for all the rules because there's so many of them. We didn't even get started. We're gonna have all the trig.
To memorize all these?
So chapter 3 is a lot of memorization of rules. Because you have to be able to apply them in chapter 4. It's just, this is, no matter where you take calculus, it's just,
It's there.
you have to know the rules first. It's like memorizing a unit circle. What's that? You need to know all the rules for the final. No, but
What if we turn in all our basket classes the rest of this year and next year?
Next year.
Well, we can usually go
no. Okay, so when we take the derivative and we have a numerator and denominator. Okay, so now instead of u times v, it's u divided by v. So it's going to be vu prime minus uv prime all over v squared. So I have this low d high, take high d low, cross the line and square the low. Okay, so this, if you want to just memorize the formula, just memorize the formula. But I'll explain the little rhyme. So low means the denominator. Okay, whenever you see the letter D, that means take the derivative of. So the denominator times the derivative of high means numerator. So denominator times the derivative of the numerator. Low, D, high. Take means minus. So low is the denominator, high is the numerator. Low, D, high. Take the bottom times the derivative of the top.
Okay.
Take, that's subtraction. High, D, low. So now what's that going to be? That's going to be, it's going to be the numerator, well, the numerator times the derivative of denominator. Well, okay, so whatever the D is in front of, that's what you're taking the derivative of. So low, so you take the denominator, then times derivative of the top, take, so that's minus, high, so that's the top part, D low, so derivative of the bottom. Then it's cross the line, so that's basically taking all of this and dividing by, square the low, so that's the denominator squared. I did, it's the, there we go. Okay, so divided, so basically cross the line is you're dividing all of that, square the low. So take the bottom part and square. So here we have x minus 4 all over 2x.
Like last week.
Okay, so I'm going to make this top part u and this v, so you can also follow along with the formula if you like. What's u prime? What's the slope of x minus 4? 1. And then what's the derivative for v? 2. Okay. Low d high, take high d low, cross the line and square the low. So low is 2x. D high, so derivative of the top part, times 1. Take high, so that's going to be x minus 4.
What does take high?
Take means subtract. High. Anytime you see high, it equals the numerator. Low equals the denominator. And D means take the derivative. Take is subtraction. Okay? So, okay, that helps more. So take high D low. So take the numerator times the derivative of the denominator. So the numerator is x minus 4 times derivative of the denominator, 2. Then it says cross the line. So here's my line. We're going to cross it, and we're going to square the low. Don't forget to put it in parentheses so you don't have to square the 2. Okay, so now it's just multiply out and combine like terms. So what do we get? 2x minus 2x plus 8 all over 4x squared. And does that simplify? Yes. The 2x is going to cancel. 8 and 4 become a 2 on the top, so 2 over x squared. So the derivative of this whole thing became 2 over x squared. Not too bad? That's as bad as it, I mean, that's this. Well, in this lesson, it can get worse. Well, that's why we're just going to practice a couple now. Okay, so we're going to, this one is quotient rule because we have a numerator and a denominator. So, if we make this u and this v, what would my u prime be and what would v prime?
It would be 1. 2x. U prime would be 1.
Oh, wait, u prime?
You say v prime.
2x plus what?
I think it's 2x plus 4.
Plus 4. And v prime is the bottom. The derivative of the bottom is 1. So let's do dy dx. Want to try that?
So how did you get that again? 2x plus 4.
So I'm going to use my power rule. 2x, that becomes a 1. Subtract 1.
Oh.
The derivative of 4x, that would just become 4x to the 0. Or just think anything x to the first would be just 1. Now, I will tell you when you have the bottom and it's a binomial, like x minus 1 squared, don't bother foiling that out. In the last problem, we multiplied it out, but that's because we were able to simplify it. Just multiply out the top. Don't foil the bottom. Usually in these cases, we just multiply out the top.
Alright, foil the top.
Yeah, there's one part that you do have to multiply out. So, did you get at least the first part? X minus 1, so low d high, take high, d low, cross the line, square the low. Did you get that for the first step? Okay. So, because the numerator can get multiplied and combined like terms, we do multiply that out. The x minus 1 squared in the denominator, in this situation, we're not going to be able to cancel anything. If we were able to cancel, you'd want it in factored form anyway. You wouldn't want to have it multiplied out. So did you get 2x squared plus 2x minus 4, and then minus x squared minus 4x? Oh, little pause in my wireless. That's not good.
Yeah, but I don't know what to do. What's it going to look like on the screen? The screen recording pause. Or not. Yeah.
There, okay, we're good. I was worried I was going to have to. Okay, so combine like terms, what do we have? X squared minus 2x minus 4. Now, from here, you can look to see if the numerator is able to factor, and then to see if we can cancel anything, but it doesn't. So we leave this. That's the answer.
And if it does, wait, say it can factor.
Then you could possibly cancel it out. Yeah. Like if you ended up with an x minus 1 in the top, you could cancel it with the one of the x minus 1s in the bottom. Okay, this is nothing different than with the whole numbers, with positive numbers. So it also works for negative integers. So the power rule is the same as before. So what would this look like? Negative 12x to the negative 5. Good. Remember, if you're taking negative 4 and you subtract 1, you're really, like, think of the number line. If you have negative 4 and you move to the left 1, you go to negative 5.
I was actually thinking about how you do it negatives when you're doing
Yeah. Now, usually when I ask you to simplify, we get rid of the negative powers. So just so you're aware that I will want you to rewrite it with a positive exponent usually. Now, here's an example. Kind of looks like it looks like a quotient rule, but I will tell you we can actually rewrite it and just use the power rule, and it would make this problem easier. So, can you think of a way to rewrite this? Well, it's going to be x squared over 2x plus 3 over 2x. So first of all, you know that kind of opposite to like finding a common denominator? Would you agree that these are the same thing? Okay. Now, I'm going to go one more step, and then I'll do the derivative, and you'll see why the power rule is so much easier than doing quotient rule sometimes. You can only do this if you just have one term in the bottom. Like if there was a plus sign or a minus sign down here, you have to do quotient rule. But here, I'm going to rewrite this as a 1/2 x plus a 3/2 x to the negative 1. Let me pause there, make sure, are we okay with how I rewrote that?
So
Because
did you just take the square and cancel out the
yeah, so x squared over x would just be x to the first. You could write x over 2, that's fine. I like to see it as a coefficient. And this is 3 over 2, and I just moved the x to the top and made it a negative 1. So now it should be pretty easy to find the derivative because we want to find the equation in the tangent line. So we'll do dy dx or y prime. What does that look like in the first step? 1/2, and then we get a minus 3 over 2 x to the negative 2. So this would look like if we wanted to just put the 2 in the bottom, or the x squared back down on the bottom.
I'm confused. Instead, 2 is like 3.
So this would just be 1/2. Are we all right with that?
Oh, yeah.
And then the negative 1 moves to the front, and then x to the negative 2. Take 1 away from negative 1 and it becomes negative 2. Okay, so now I want to find the equation of the tangent at x equals 1. So what do I need to write the equation of a line? I need the slope, and I need the point. So far I have the formula for the slope, and I have the x coordinate.
So you do not find the common denominator.
Oh, you could if you wanted. I wouldn't bother. Okay, if you're finding the, this is simplified enough for me. I don't need you to go any further.
Oh, really?
Yeah, so this is dy dx, which happens to be your slope, right? Derivatives are slope. So if I want to find the slope, I can find it now at any point, but I specifically want when x equals 1. So let's take dy dx and evaluate it at x equals 1. Oh.
They should love it.
There you go. So remember that line just means evaluated at x equals 1. So what do we have? It'll end up being what, 1/2 minus 3/2? See, we didn't really have to worry about finding a common denominator because when we plug in 1, it has the common denominator. What do we end up with for?
1.
Okay. All right, so that's my slope, right? There's m. I have x. How do I find y? Okay, so y of 1 is 1 squared plus 3 over 2 times 1. What do we got? 2. So now my tangent line is what? Y minus 2 equals -1 is x minus 1. Perfect. That's easy to put in slope-intercept, but we can leave it that way. Oh, it's thinking again.
Wait, x minus x plus.
It's there. Yeah, did anybody put, if you want, you can put it in slope-intercept. A little bit more. Ah, this is the last page. Just double checking. Okay, so Matt was asking if we can keep going, and we can. Oh, it's thinking. So on the next page, it says second and higher order derivatives. So you can keep going. You could keep finding the derivative after the derivative after the derivative. Sometimes it gets easier and easier as you, like a polynomial. If you keep taking the derivative of a polynomial, you will eventually get to 0. Because think about it, every time you take the derivative, you get one less degree. And then you take the derivative again, you get one, like it keeps going down. So this is notation, just so you're familiar. This is y double prime, triple prime. Then after 3, we put a little parentheses around, like if I said the 10th derivative, we just put a 10 with parentheses around it. This is other notation. This is the second derivative with respect to x. This is the third derivative with respect to x. Okay. It's just notation.
Sure.
Sure. So let's find the first. I know, it's really windy.
Forward derivative.
Okay, so here's my first derivative. I'm going to use this notation just because the other notation's easier, but this one is used more often later on. That's why I'm using this one.
Which one?
Oh, dy dx. I'm using this. Awesome.
Is it d4 y over
dx for.
Okay.
There we go. Okay, what do we... Yeah, it's okay. I'm just going to write it out. Keep. There we go. All right. You got to 0? There we go. So the first...
test, will you say like
Use blah, blah, blah.
I don't know.
I'll tell you, like, find the first 4 derivatives, or I'll tell you, usually on a quiz or a test, I'll say, find the 4th derivative of.
But you don't care if it's like y prime or dy dx.
No. Okay, what do we get for the first derivative? 3x squared minus 10x plus 0. What's the second derivative?
6x.
Third derivative. Fourth derivative. Perfect. So you see how with a polynomial, even if you had a polynomial with x to the 100th, right, you're eventually going to get to 0. How many times would that take? I'll just think. If this is the third power, and it took the 4th derivative to get to 0, if you had x to 100, when would you get to 0? How many derivatives would you have to do? 101. You need to do one more. So, because this is the third, it took the 4th derivative to get to 0. So, there you go.
You know where they have
We are. We got through the whole section. I had 2 days for this. Wow.